That you can make your parents proud, you can make your school proud, you can touch millions of people's lives, and the world will never be the same again because you came this way. Don't let nobody steal your dream. After we face a rejection and a no, or we have a meeting and no one shows up, or somebody say, you can count on me, and they don't come through. What if we have that kind of attitude? The cause repossessed. Nobody believes in you. You've lost again and again and again. The lights are cut off, but you're still looking at your dream. You're doing it every day and saying to yourself, it's not over until I win. You can live your dream.
Okay, guys, I certainly hope that you like that little intro of motivation. I try to do that every morning just to get my juices flowing. But alrighty. We're moving on to chapter 34, dilutions. I will admit it did take me a little while to kind of do some of these problems, but that's just because I haven't done them in a while, and I'm trying to figure out a way to explain it to where it would make some sense, like in real life. Okay. But yeah, these are a little on the more advanced side, but you should be fine if you follow the examples in the book. Most of the problems follow one of the examples in the book, in the chapter. So let's just start off with saying, starting with the paragraph. Sometimes it's necessary to dilute a concentrated solution before dispensing. You may need to calculate the percent concentration of a final volume. You may need to prepare a certain percent dilution and calculate the amount of diluent to add to an available solution. In the following examples, note the phrases in italics. It's important to distinguish between solutions that are diluted to a certain volume and solutions that have added additional solution added to it. So basically, diluted solution is when you add a neutral to the volume, and then when you're adding additional solution, it's like you're making, well, I guess it's the same thing, but like when you're diluting, you're adding more of a neutral, and then when you're adding additional solution to make a final volume, you're also diluting. Like basically you're diluting, but in two different ways, I guess. I don't know. That didn't come out right, but let's continue anyway. Okay, so our first example states if 500 ml of 30% solution is diluted to 600 ml, what will the percentage of the resulting solution be, right? So it shows here that in order to figure this or these types of problems out, you need to conduct two steps, okay? You first need to figure out what 30% means in grams of drug, okay? So first step is calculate how many grams are contained in 500 ml of a 30% solution. So 30% means 30 divided by 100, right? So that's how you start this. Your 30 divided by 100 would be what in 500? Okay, that's basically what it's asking. And then you do your crisscross. 30 by 500 equals 100x. Okay, and 30 times 500 divided by 100 gives you the 150. So if you were to visualize, because I know I do my crisscrosses, 30 times 500 on one side and 100 and x on the other, and then you divide 30 grams times 500 over 100 to get the 150. Okay, so now you've established that 30% in 500 ml is equal to 150 grams of powder, okay? So, or basically 30 grams in every 100, which is 150 in every 500, okay? So now you would move on to your second step, okay? Because it's asking how many do I put, or what would the percentage be if I were to add 100 more mLs to make it 600? So obviously, if you're adding more of a neutral, your percentage would go down, right? So step 2 would be, okay, well, if I'm still using the same 150 grams in my formula, okay, and this time I'm using 600 ml to get, or I'm using 600 ml in total, then what would my percentage be if I did this? Okay, so that's basically the 2 steps. First steps is figure out what your percentage means in the current state, and then the second step is what it would mean in your newer state, if that makes any sense. Okay, so my 150 grams, if I still have 150 grams, like for example, if you add Kool-Aid powder to water, but then you add more water to the Kool-Aid, it's going to be a less percentage of Kool-Aid, for example. So in this case, you have 30% of Kool-Aid in 500 ml. What percentage would it be if you added more water? Okay, and obviously it's becoming diluted, so it's going to be less strong, or less red, let's say, in theory. Okay, so 150 grams over 600 ml equals what in 100 ml, right? Because we always want to find, if we're looking for a percentage, we want to find what that number is. So 150 gram times 100, okay, equals 600x. And we divide by 600 in order to get our 25 grams, which would also be considered 25%. Okay. In this video, actually, I'm going to do all of the examples because it's crucial that we understand what it kind of means. Okay. All right. So that's how we get a percentage. Like, what is our percentage? Okay. Kind of answers. And number 2 states we have, or the second example, we have 200 ml of a diluent that's added to 300 ml of a 35% solution. What is the final percent concentration of the diluted solution? Okay, so technically you have 350 ml that's currently 35%, but then you're adding 200 ml. That's what the question really looks like if we think about it. Okay. All right. So what is the final percentage if we were to add another 200 ml to this 35% solution? So again, we need to find out what 35% means. To find out what 35% means, you divide it by 100. 35 grams or 35%, right? Over 100. So 35 over 100 is the 35% per 100. 35 over 100 equals what in 350? So if we have 35 grams in 100 ml, how many grams would we have in 350 ml? So 35 times 350 over 100x equals 122.5 grams. Okay, so basically if you take 35 and you multiply it by 3.5 times, same thing, I believe. Yeah, it's the same thing, but you just don't go do the whole crisscross. But for learning's sake, do the crisscross. 35 times 350 equals 100x. Divide by 100 to get your 122 grams. Okay, it states here, note the final volume is determined by 200 plus 350 ml. Right, so we currently have 122.5 grams in our cup of Kool-Aid, let's say. All right, because I guess I started with the Kool-Aid analogies or things. Okay, so now we're we have 122.5 grams in our original, what was it, 350? In our original 350, we had 122.5 grams. But now we're adding another 200, according to the problem. Okay? So our 350 plus our 200 gives us 550 ml. So now we're looking to see what is the percentage in strength that the 122.5 will be in the 550. So if 122.5 is in 550, then how much is in 100? Okay, that's basically what this says. Okay, so 122.5 times 100 divided by 550 is 22.27 grams per 100, which also means percent per 100. Okay, so your percentage would be 22.27%. Okay. All right, our third example says, you mix together the following volumes of the same drug. So you have basically 3 drugs, and you put them all together. And you want to know what percent concentration of the final solution. What's the final solution after you mix all of these together? Okay, so your first drug is 150 ml of 20% solution. Your second drug is 50 ml of 35% solution. And your third solution is 20 ml of 50%. So now if we throw all these things in the same pot, right? What percentage will the final concentration be? Okay, so again, in order to figure out anything, we need to know what it means to be in 100. Okay, so step 1 is technically figure out what it means to be in 100 before you move forward. Okay, so if you have 150 of 20% solution, right, you need to figure out what would be in 100. So if 20% is in 100, so 20 out of 100 equals what in 150, which actually would be 20 times 150 divided by 100 would give you 30 grams. Second drug would be 35 grams, because it's 35% solution. You ask it to be, what if it's 35 in 100, then what would be in 50? And in this case, you can kind of see, if you have 100 ml and you have 35, then obviously in half of that, you'd have half the grams, right? So that's what it's saying. Okay, and then C, you have the 50, you have 20 ml of 50% solution. Okay, so the 50 grams in 100 is what in 20. Okay, all right, totally what you have, which it's saying here, after you figured out exactly how many grams of powder you have in each of these medications, you then have to add all of the grams. So 30 plus 17.5 plus 10 gives you 57.5 grams, right? That's one. Number 2, you need to dilute it or figure out what is the total amount of mLs you're actually working with. So in this cup, I guess, you have 150 ml, you have 50, which makes it 200, and then you have 20 ml, right? So 150, 50, and 20 gives you a total of 220. So in this cup, you have a total of 57.5 grams, and the cup size is 220 ml. Okay? So now we'd like to know what the percentage would be, because it's asking what is the percent concentration of the final solution. So we put all this stuff together, we mix it, and we want to know now what is the final percentage of everything. Okay? So if 57.5 grams, which would be technically, if this was 100 ml, the percentage would be 57.5. But because it's 220 ml, we need to figure out how much will be in 100 ml. So 57.5 grams over 220 ml would be what? How many grams in 100 ml? Okay? So then you do your crisscross. 220x equals 57.5 times 100. Where did I get this 35 from? Give me 1 second. I don't know what they're doing right there, but technically you should be 57.5 times 100. I guess they dropped it, or they reduced it. They reduced it by lowest terms in this case. But you can do it this way also. Let's just do one of these. 57.5 times 100. So first we have the 220x equals 5750. And then if we divide that by 220, because I like to keep it simple. You divide that by 220, you get 26.136, which is 26.14, which is the same difference here. Okay? Do it this way. Keep it simple. You don't have to shrink all your numbers before. I really normally don't mind working with bigger numbers just because I keep it organized in my head. So this whole thing is the same thing as doing it with the big numbers. So keep it that way if it feels comfortable. If you'd like to reduce it, then go ahead. But I personally like to keep it big. Or as common sense as possible, because then I reduce my chances of confusion. Okay. So I do it this way. You can shrink your numbers by common factors and stuff like that to make it easier to work with. But yeah. So this is what I did. And this is how you get your percentage. Okay? Let's note here, when calculating a dilution, the amount of drug in a container does not change, but the amount of diluent increases. So keep that in mind. Okay. So that's why you're stuck with the same grams, regardless if you add more or less liquids. Okay. The last example, let's see if you can, I'm going to try to throw that in there. Last example, you're to prepare as much as 40% dextrose solution as you can from 200 ml of 70% dextrose solution. How many ml of water do you need to add to the 70% dextrose solution? Okay, so what is it really saying? You are to prepare as much as 40% dextrose solution as you can from the 200 ml of 70% solution. Okay, so that means your water would be endless, right? Because as long as you're getting 40%, you can add more water and it'll still be, you can dilute the 70 and still get more. That was something that kind of gave me like why are we adding more water and we're only working with this situation. But as long as you get a 40% end result in your bag, you can add the water as needed. And you'll see what I'm talking about down here. Okay, so number one, it says, calculate how many grams of dextrose is contained in the 200 of 70% dextrose. Again, whenever we have a percentage or a ratio of any type, we want to look at what is the percentage considered in 100, and then figure out what it is in what's given. So in this case, it's 200. So 70 grams in 100 equals 70%. So because we're looking for 200, you can see that it's doubled, right? And it's still 70% because that's what that means, okay? So 70 grams in 100 is 140 grams in 200, okay? You can see that by doing the crisscross. 100x equals 70 times 200, divide by 100, and you get your 140 grams. Okay, then you want to figure out how many ml do you need to add in order to make it 40%, right? So 140 grams is available, okay? In this baggie right here, there's 140 grams of drug, and currently it is 70%. But if you were to add more, you want to make it 40%, how much more do we need to add to make it 40%? So again, part 2 of this is figure out what the 40 is in 100, and figure out if we have 140, then how many do we need? How many ml do we need? Okay, so then you get the 40x, and again, 100 times 140 divided by 40x, or 40, gives you 350 ml final solution. Okay, so what does that mean? If this is 200 ml, let me get that in a picture. If this is 200 ml and it's currently 70%, in order to make it 40%, the total water in this bag needs to be 350 ml. Okay, so that's what that means. Let's continue on part 3. If you currently have 200, which is considered 70%, but you need 350 in order for it to be 40%, how much more do you need to add to your 200 in order to make it 40%? Okay, that's pretty much what it's saying. So if you need 350 and you have 200, you need to add 150 in order to get, or in order to make this bag 40%. Okay, I hope that certainly makes sense. We're going to do some problems now from the book. And I did a lot of scribble scrabbles, so bear with me, because I myself was trying to figure this out on how I'm really going to do this. Okay, let's go to number 1. I know I did 1 through 5 for sure, and then they started becoming similar, so I started skipping like always. All right, number 1. You have 200 ml of a 30% solution. You dilute the solution to 600 ml. What's the percentage strength of the final solution? Again, figure out what's in your current solution, which is if 30 is in 100, then what is in 200? And we see here that I got 60. Okay. Then if I have 60 grams in total, and my solution at the end of the day is going to be 600 ml, 60 and 600 ml equals what in 100 ml, so I can figure out a percentage. And that's how I get my 10%. So the first step is figure out what's in your current solution. Second step, use the grams to figure out the percentage in your new solution. Okay, that's what I got from this. Number 2, what is the percentage strength of a solution that's made by adding 200 ml of purified water to 600 ml of a 25% solution. Okay, let's figure it out. First we first have 600 ml of 25% solution. So let's figure out what that means. 25 and 100 means 25%. So what does it mean in 600? Okay, so 100x equals 15,000 in total. If we divide it by 100, this bag right here, the 600 ml of 25% solution, has 150 grams of pure drug or pure powder, okay? Now, we want to make this solution 800 ml, right? Because it's asking you to add 200 ml. So obviously when you're adding more ml, your percentage dilutes, right? It becomes less then. So that's one way to make sure that that's one way to check to see that you're doing it right. It should be less. When you're adding more liquid, all right, or when you're diluting, your percentage should be less than what you started with. Okay, so now you have a total of 150 grams in your baggie, okay? And you're going to add another 200. So in your 600 ml bag, you're adding another 200. So your total mLs will be 800 ml. And you still have 150 grams of drug in there. Okay, so now you just want to know how strong it is. So 150 in 800 is what in 100? It's basically what it means. So we crisscross 150 times 100. 800x, all right, so 800 times x is 800x, 150 times 100 is 15,000, divided by your 800, you get 18.75, which is your new percentage strength. All right, this one gave me a little headache, but then I figured out what I was doing, so then I just relaxed. I think it was this one. No, maybe it wasn't. Okay. I think it was because I got the scribbles. I don't know. But anyway, number 3, you dilute 50 ml of an 8% solution to 500 ml. What is the percentage strength of the resulting solution? Okay. So again, 8% is 8 divided by 100. 8 divided by 100 equals 0.08. We multiply that by 50 to get 4 grams, right? Then, again, we do the same steps. 4 grams in a total of 500, because that's what we're doing. All right, because it's saying you dilute 50 ml of a solution to 500. So your maximum will be 500, not 550. Okay? So then you get your 4 grams in your 500, and you you crisscross x into 100. You get 500x equals 400. Divide that by 500, and you get your 0.8%. That's how, what is the percentage strength of the resulting solution? You get 0.8%, because that's what it's asking for. Give me one moment. I need to get my charger. Okay, I'm back. I know that was 0 time for you, but anyway. Let's move on to number 4. Okay. Number 4 states a technician has been given 100 ml of a 10% acetic acid solution. The pharmacist asks the technician to dilute the solution to 500 ml with sterile water, and then to label the solution. What percent should appear on the label? Again, just like we've been doing, first figure out what's in 100, because it's percent. In this case, we do our 10 divided by 100 equals 0.1. Then we multiply it by 100 to get the 10 grams, right? Same thing as if we did the crisscross, as 10 over 100 equals x over 100. It's the same thing, but you get 10 grams, right? 10% in 100 ml is 10 grams. Okay? It's just like pennies. 10 pennies in $1. 10 pennies in $1. 10% in 100. Okay? All right. Now we have step 2. What would be our percentage if our same 10 pennies, let's say, was in $5 versus $1? Okay? So 10 grams in 500 ml equals what in 100? Our percentage would be 2 after doing the crisscross. Same difference. Okay, number 5. A 20% solution has been diluted to 400 ml and is now a 5% solution. Okay. What was the beginning volume of the 20% solution? Well, 5 divided by 100 equals 0.05. If we multiply that by 400, we have 20 grams. Okay? What I simply did, I figured that if I figured that 20% divided by 5 gave me 4. Okay? So then I did the same thing with the mLs. 400 ml divided by 4 is 100 ml. It's a different setup, but I did it based on how I understood the question, and that's how I got my answer. Okay. So you can follow one of the examples to make it, to do the whole crisscross thing. But I did it in this way. Okay. Let me see if we got number 10. Do I fit all of that in there? I'll move it as needed. Okay. You're preparing a TPN with 500 ml of 7.5% Travasol and 500 ml of 50% dextrose injection. Okay? What's the final percent concentration of both? Okay? So again, first we need to figure out what it means in 100. Okay? Travasol, 7.5 divided by 100 gives us our 0.075. If we multiply that by 500, we get 37.5 grams of powder, of Travasol powder in this solution. Okay? Or drug. I always say powder, but it's drug. Then you need to find out the dextrose. The dextrose apparently is 50% in 500. So 50 divided by 100 is 0.5. We multiply it by 500 to get 250 grams of powder or pure drug. Okay? So now we want to figure out what the percentage is technically when we put both of these in the bag. Again, we just need to figure out 37.5 grams, which is our Travasol, when we're looking for Travasol. And because the bag is because the bag is 500 plus 500 ml, right? A total of 1,000 ml. Because the pure drug doesn't go anywhere, but the 1,000 ml increased, or the liquid in the bag increased. So it's not going to still be 7.5% because there's another 500 ml in that situation. So now you say, okay, well, if that 37.5 grams is now being diluted by the 1,000 ml, what is the percentage? What would be considered the percentage? Okay, so what would be in 100? If 37.5 is in 1,000, what would be in 100? Okay, so you do the 37.5 times 100, times 100 is 3750, and 1000x is 1000x, right? Divide that by 1000, you get 3.75. Okay, or 3.7, however you want to put it out there. However your answer is available. Okay, so the Travasol in this solution, in this bag, is now 3.75% because it's mixed with, or it's been diluted from the original 500 ml. Okay. Our second, we do the same thing, but with the dextrose. We have a total of 250, and we're adding it in 1000 ml. So what's in our 100? We do our crisscross, and we make 25%, or we get 25%. So in this bag, our label would say that this is Travasol 3.7% and dextrose 25%. And that's that one. Okay. Moving on to, I guess, number 26. All my things are a little mixed up, so I'm just going to pull them out and do them. Number 26. Let me see. Do I get all that in there? Okay. So, number 26 states, in a pharmacy, there are 3 different percentage strengths stock solutions. Okay, of the same drug. So all of this is the same drug, it's just different strengths. If these are all mixed together, how many ml and what percentage strength will the result be? Okay. So we have 120 ml of 75%, 54 ml of 10%, and 20 ml of 8%. If we add all of those mLs together, we get 194 ml. Okay. So your first part of your answer, if it's all mixed together, how many ml would you have, right? Your first part of your answer would be 194 ml. Okay, now we got to figure out how strong it's going to be. Here it says 50%, but let me tell you how I got that. Okay. In each case, we need to figure out what each strength is in 100, so we can figure out how many grams is in the designated mLs that they were given. So for number 1, we have 120 ml of 75%, which means 75 divided by 100, right? Or 75 over 100 equals what over 120? So you get 90 grams, okay? So if in 100 ml you have 75 grams, then in 120 ml you have 90 grams. Okay, that's what this means. And straight down the line, if in 10 ml or if in 100 ml for the second part, 54 of 10%, if in 100 ml you have 10, right, because that's what makes it 10%, then how many would you have in 54? Do your crisscross, you get 5.4 grams. Number 3 says 20 ml of 8. Okay, 8% means 8 out of 100. So if in 8 out of 100, or if you have 8 in 100, then what do you have in 20? And your answer is 1.6 grams. Now, what we need to do in order to figure out our percentage is add all of these grams together. Okay, 90 plus 5.4 plus 1.6 grams is 97. Okay, now we have 2 parts. Our last step is if we have 97 grams of the drug, right, in 194 ml that we totally have. So in this entire mixture, we have 194 ml. And we also have 97 grams worth of powder in that mixture. Then what would we have in 100? Okay, so 97 times 100 is 9700, and 194x is 194x. If we divide 9700 by 194, we get 50%. So our total would be, or our answer would be 194 ml. That's 50% strong, pretty much. Okay. And let's go into number 27. This one has a better, or one of those explanations. Okay. A 1 in 1,000 weight volume solution is required by the patient. On hand in the pharmacy is 20 ml of a 1 in 250 weight volume solution. How many ml of the 1,000 weight volume solution can be made from the stock solution? So sometimes you're going to get questions like this and it's just going to be like, oh my God, what the hell? Okay, but what is it really asking? First, what we need to do is figure out what these little what these semicolon mean in percentages. Okay. Whenever you have parts, it means 1 in 1,000 parts. So if 1 in 1,000 parts, if you divide 1 in 1,000, you get a total of, for example, 0.01. Okay? But you want to make it a percentage so we know what we're doing here. Okay? So 0.01 and you multiply it by 100 and you get 0.1%. Okay? So that's part 1. You need to figure out what 1/100 or 1/1000 weight volume solution is. Okay? So it's the same thing as saying 0.1%. We learned this in our previous chapter. I'm not sure. I think it was 30, 33, one of those. But 1 in 1,000 means 1 divided by 1,000. Okay? And if you want to make it into a percentage, you multiply it by 100. So we can make it a percentage. So now our 1 in 1,000 equals 0.1%. Okay, that's part 1. And we want to do the same thing with our 1 in 250. Okay, because right here you see 1 in 250 or 1 semicolon 250 weight volume solution, which means the same thing as 1 divided by 250. You get 0.004. You multiply it by 100 and then you get 0.4%. So now you have 2 percentages. Okay, instead of saying it this way, 1 in 1,000 weight volume solution, you say a 0.1% solution is required by the patient. On hand in the pharmacy is 20 ml of a 0.4% solution. Okay, how many ml of the 0.1% solution can be made from the stock solution? So now that we have percentages, we can kind of go back to our old formulas, how we were figuring these things out. Our first step is if our 0.4, right, because that's what we have available, if our 0.4%, okay, so 0.4 divided by 100 or 0.4 in 100, right? We have 0.4 in 100, then how much do we have in the 20? The reason why we start with this one is because this is our given. On hand in the pharmacy is 20 ml of the 0.4 or the 1 in 250. Okay, so we start with this to figure that out. 0.4 in 100, then what is in 20? We crisscross. 100x equals 8 divided by 100 equals 0.08 grams. Now we know we have 0.08 grams in 20 ml. Okay. Now it's asking us how many ml of the 1 in 1,000 weight solution, 1 in 1,000 weight volume solution can be made from the stock solution. Okay. So if our grammage is 0.08 grams, how many can we make if we have 0.1, right? Because this means grams too. We have 0.1 grams in 100. How many ml can we make? Because that's what we're looking for if we use 0.08 0.08. If we have 0.08 grams, in how many, right? So if, okay, let me just collect my thoughts real quick. If we have, the translation would be, if we know that 0.1 is in 100, then how many will be in 0.08? Okay, how many are we looking for, or how many can we make? So we do the same thing. 100 and 0.08 and 0.1x. So 0.1x and 100 times 0.08 will be 8, right? And then when we divide by 0.1, we get 80 ml. Okay? And the reason why we're asking, or we're placing this here, is because it's asking us how many ml of the 1/1000 solution can be made from this solution. Okay? So your answer would be 80 ml. Let me see. Okay. Number 34 states, a technician is asked to prepare a 42% solution. In stock in the pharmacy is 350 ml of a 55% solution. How many ml can the technician prepare if she uses all of the stock solution? Okay, so first off, you have 55%, or basically 55 out of 100 means 55. And because you have the 350, you're looking at, if 55 is 100, then what is in 350? So you have the 192 grams. So in this 350 of 55% solution, you have 192 grams of powder. By doing your crisscross, you figure out that you have 192 grams of powder, 192.5 grams of powder in that bottle or that little cup. Okay, that 350 ml is mixed with 192.5 grams of Kool-Aid. All right, so let's do the Kool-Aid thing again. You have 350 ml and 192.5 grams of that is Kool-Aid powder. Okay, now it's asking you to dilute it to 42%. So you need to add more to it. Okay, so if 42%, so 42 over 100, basically, if you have 42 out of 100, then how many can you get out of 192.5? Okay, so 100, because your grams go to with your grams and your mLs go with your mLs. Okay, let's put that there. Let's fix that. Okay, so 42 grams in 100 ml, but we have 192.5 grams in how many ml? Okay, we do the crisscross, we get 458.3 ml. So technically, in order to make this a 42% solution, you would add 108.3 ml, right? 350 minus 458. So 350 minus 450 is 100, and then 108.3 ml. In order to dilute it, you would add more. You would add another 108.3 ml to dilute it to 42%. Yeah. Pretty much. Okay, let me see what else I have as far as examples for this chapter. Give me one moment. I think I'm going to do this one because the video is running a little long on this. Okay, number 14. I know I skipped around and I went all over the place, but let's do number 14. If you mix 100 ml of a 1/100 solution with 350 ml of a 1/200 solution, What's the percentage strength of the final solution? And what is the ratio strength of the final solution? What I personally did is if I had one 100 and one 200, I basically had 2 out of 300 parts. And that's how I got my 0.6%. Right? Because that's what it is. 1 out of 100 and 1 out of 200 is 2 out of 300. 2 divided by 3 is 0.6. Okay? And that's how I got that. Now, when I was looking how do I make the ratio, if I wanted to make it into a ratio, I just did 100 divided by 0.6 and I got 167. So it'll be 1 out of 167. Actually, this one was pretty. This one's another simple one. 24. An order is for 60 grams of a 3% solution. On hand is 100 grams of a 10% ointment. The 10% ointment must be diluted with petroleum. How many grams of each ingredient must be used? First of all of this other stuff right here, all you needed to know is that the order needs to be 60 grams, 3%, and petroleum is your diluter. Because regardless of how strong this is, in order for it to be 3% of your 60 grams, you need it to be 18 grams strong. So what you would do is divide your 3 by 100 to get your 0.03 and multiply it by 60 grams to get 18 grams. So 18 grams needs to be your drug ointment. 18 grams of your drug ointment. And then because you need to make it 60 grams, you just quantity sufficient with a neutral, which is 42 grams of petroleum. Petrolatum. Oh, petrolatum. I thought it was petroleum, whatever. So all of that extra, I don't know. I didn't need it to figure this out. But whenever you have a 3% and you need it to be 3% of anything, you must first understand that in order for it to be 3%, it needs to be 3 out of your 100. So you divide your 3 by the 100, you get your 0.03, and then however many you need here, which is in this case 60 grams, you would multiply it by the 60 in order to get a total amount of pure powder in grams, or whichever part of that needs to be pure. And then you just quantity sufficient up to the remaining amount with the neutral. That's how I do it. That's how I figured this out. But yeah. And let me see here. And I guess I have a little more. Let's figure. This one was actually kind of tricky because you had to know some things without it being stated. Okay. So number 40 states 400 ml of sterile water for injection is added to a liter of normal saline solution. What is the percentage strength of the resulting solution? Okay, so our first thing is normal saline is not. Normal saline is your percentage in this equation because it's 0.9, and that's just a common thing that you should know generally in pharmacy. So 0.9 is your percentage. This is where your percentage is without it being stated. Okay, so that's how you know that this is 0.9, because normal saline is 0.9. Okay, period. Okay, so 0.9 out of 100 is what out of 1,000? Because you're adding 400 ml of sterile water, right, to your 1 liter, which is 1,000 ml of normal saline solution, which is 0.9%. Okay, so if 0.9% out of 100 equals to what out of 1,000? So in order to get the 0.9%, you need 9 grams in your 1,000 ml. Okay? Then you get that 9 grams and you say, well, I have 9 grams in a total of 1,400 ml, right? The liter, because you're adding the 400 to the liter. 1 liter is 1,000 ml, and 400 ml is what you're adding. So you have 9 grams in 1,400 ml. So what would my percentage be if I had it in 100 ml, right? That's basically what it's asking. So 1,400x equals 900 over 1,400. Which gives you the 0.64%. So now rather than being a liter of 0.9%, you have 1,400 ml of 0.64%. Okay.